Hello, my name is Aman Sharma and I am your mentor for CSE at YourPedia Education. So today we'll be solving a question from our NPTEL question bank series. So the question that we have selected is from operating system, and you can find the question on page number 152 of the booklet. It is question number 7. In Peterson's algorithm, if the turn variable is not present, that is we only use the flag variable, then the resulting solution will violate which condition? So we know that Peterson solution satisfy all the 4 conditions that we need to achieve synchronization. So if we don't use the turn variable in that and only use the flag variable, which condition will be violated by our solution? So let's see. So Peterson algorithm and turn variable is not present, only flag variable is present. So let's see first how the Peterson algorithm works. So this is the Peterson algorithm. It is used for 2 processes, and we use a flag variable and a turn variable and then a while condition, and after that we see how the 4 conditions are satisfied by this solution. So let's see how these 4 conditions are met. Now let's say P0 enter and wants to use the critical section. So there is a flag variable first, flag variable for 0 and flag variable for 1, and there is a turn variable which we will put 0 or 1. So let's see. P0 enters the critical section. On the first statement, initially the flag value will be false. So it makes the flag 0 as true and the turn variable as 0. So we have moved to the third condition. Now the third statement is while flag 1 equal to true and turn equal to 1. So it is a while loop, but it is used as a trap condition. What do we mean by trap condition? If the condition that is inside while loop is true, our code will not move forward. As while is true, it will remain in that code in that loop. But if any of the condition is false in this while loop, then it will move forward and enter the critical section. So as of now, flag 1 equal to true. Now we know flag 1 is false, so this condition is false, and false having and with any condition gives false. So this while condition fails and we move to the critical section. So critical section is achieved by P0, or we will write it here. Critical section is achieved by P0. Now let's say P1 comes. Now P1 will run its 5th line, flag 1 equal to true, turn equal to 1. Now when it enters the while loop, flag 0 equal to true, which is a true condition, and turn equal to 1, which is also a true condition. So it will get trapped inside this while loop. So it will not move forward after that. Now let's say P0 completes its critical section. Now when P0 completes its critical section, it will move out of the critical section and it will complete its 4th line of code, which is flag 0 equal to false. Flag variable value is changed to false. Now when we move to the 7th line of code, P1, while flag 0 equal to true, now flag 0 value is false. As the flag 0 value is false, this condition will be false. It will come out of the while loop and enter the critical section. So when it enters the critical section, P1 will have access to the critical section. So this is how Peterson algorithm works. Now we have seen that when P0 was in critical section, P was not able to enter the critical section. So this means that mutual exclusion is satisfied by the Peterson's algorithm. So now let's see about the second condition. Second condition is progress. Now in progress, what does progress means? If one process does not want to enter the critical section, it should not stop the other process to enter the critical section. So let's say P1 does not want to enter the critical section. So flag 1 value will never get equal to true. It will always be false, because in order to make flag 1 equal to true, P1 should access or should have interest in using the critical section or should run this code. But P1 is not interested, so flag 1 value will always remain as false. Now if flag 1 value is always false, this statement flag 1 is equal to true will always fail, and if it always fails, P0 will always be able to enter the critical section. So P1 not having interest in using the critical section will not stop P0 from entering the critical section. So obviously progress is satisfied. Now there is no requirement for any hardware changes for implementing Peterson section. So obviously hardware condition is also met, and fourth condition is bounded wait. Bounded wait means that you need not to wait indefinite amount of time to get your turn. Like you need to have information about the after how much time you will get the critical section. So let's see how the bounded wait works. So for bounded wait, what we can do is, let's say P0 enters into the critical section and the flag values are it's true now and it's false and turn variable equal to 0. Now this is the condition for bounded wait. Similar to this critical section, P0 is in critical section, similar to this code. When P1 enters, it will not be able to enter the critical section because there is a mutual exclusion condition here. But when P0 comes out and P1 has changed all the flag and turn values and is sitting in the while loop, as soon as P0 comes out of the critical section and flag 0 value is changed to false, then at that point P1 will be able to enter the critical section. So there will be no indefinite time waiting for the process P1. So bound wait is also satisfied by our Peterson algo. Now this is Peterson algo. It satisfies all the four conditions. Now what the question is saying is, if we don't use the turn variable, we use only flag variable. So then what condition will be violated by that? So let's see. If we remove the turn variable, our code will look like this. There is only flag variable here and while condition is only checking flag variable. So let's see. First we will look for mutual exclusion. Now for mutual exclusion, let's say that P0 comes, there is a flag value here, flag of 0, flag of 1, which is false. Now P0 comes, it makes the flag 0 value as true, and at second condition flag 1 equal to true is false, so it will enter critical section. And let's say we preempt this. Now when we preempt this, if P1 wants to enter the critical section, it will make the flag 1 value equal to true, flag 1 value equal to true. But when we go into the while loop, flag 0 equal to true is checked. Now flag 0 equal to true is a true condition. When this condition is true, it will keep on looping inside the while loop. It's a trap. So it will remain at the 5th line of code, 4th, 5th, and it will remain here. Now when P0 comes out of critical section, it will make its flag value equal to false, and then the while loop will fail, and then P1 will be able to enter the critical section. So there is no way in which that two processes are simultaneously entering the critical section. So obviously mutual exclusion is satisfied. It is not violated. Now let's see about the progress. Now in progress, if let's say P1 does not want to enter the critical section, so flag 1 value will never be true, it will always be false, and whenever P0 checks this while condition, flag value 1 equal to true will always fail, because if P1 is not interested, flag 1 value will never be equal to true. So this will false always, and P0 will be able to take the critical section. So by this we can say that progress is also satisfied. And now hardware situation, we don't need to change anything in the hardware to implement this code. So hardware condition is also met. Now let's see about the third condition, which is bounded wait. Now in bounded wait, let's say P0 comes and makes the flag value as this is false, makes the flag value as true. Now let's say we preempt this P1 at this point, P0 at this point, and P1 enters the code. Now when P1 enters, on fourth line of code it will make the flag value 1 to true. Value of flag 1 will be changed to true. Now if you want to preempt here, you can do this also. If you want to preempt this, you can do this also. But let's say we keep on running this code. Now at the fifth condition, while flag 0 equal to true. Now while flag 0 equal to true, now value of flag 0 is true. So this will be, the code will be trapped here because while condition is true. So it will keep on looping here and will not be able to access the critical section. Now let's say we again preempt this and move back to the P0 code, and at P0 we will check the second condition. Now flag 1 equal to true. This condition is also true because we have changed the value of flag 1 equal to true. Now if this condition is true, it will again, this loop will also get trapped. Now there is no way to change these flag values to false, because in order to change the flag values you need to enter the critical section, and when you leave the critical section you will change the value of flag to false, like flag 1 equal to false, flag 0 equal to false. But there is no way to enter the critical section. If you are not able to enter the critical section, you will not be able to change the value of flag. So both the cases are trapped here. So what it is a form of deadlock. In order to move to the critical section, some flag value should be false, and in order to change the value from for a flag from true to false, you need to enter the critical section. So it is a perfect example of deadlock. You are not able to move forward, and to move forward you need to access this part of the code. So you are trapped here. So deadlock is there. So when deadlock is there, there is no knowledge of how much time it will be required for the code to run. So it is an indefinite amount of time. So yes, bound wait will not hold. So if we remove the turn variable and only use flag variable, our bound wait condition will be violated. So the answer to the question number 7 is, in Peterson algorithm, if turn variable is not present, the solution uses only flag variable, the resulting solution will violate which condition? Bound wait. So the correct option will be C, bound wait will be violated. So I hope you understood the concept of Peterson algorithm and how the turn and flag variables work. So keep on watching our YouTube channel for more videos like this and keep preparing. Thank you.